Hi, I'm going to talk about calculus a little bit to give you some basic concepts about it. What's calculus and when do we use calculus? Calculus is a mathematical tool that helps us to compute the rate of change. It also helps us to compute the volume or area of an object. However, I'm going to talk about how to use calculus to compute the rate of change at a specific time, which is called instantaneous rate of change, using the following simulation type example. As you see over here, I have a rod that is about 29 centimeter long, and also there is a time at the bottom in seconds from from 0 all the way to 50 seconds. All right. Now my goal is I'm gonna move this car at a constant speed from 0 all the way to 6 centimeter with the same speed. Then the car is gonna stop moving for about 4 seconds, which is from 12 to 16 seconds. The car is gonna stop moving. Then the car is gonna start moving again after 4 seconds and move with the same speed as previously all the way to 16 centimeter. However, after 16 centimeters, the car is gonna accelerate or speed up and get at 22 centimeter in 1 second, from 16 to 22 centimeter in 1 second. And then it's gonna accelerate more and get at 29 centimeter in 1 second. Okay, from 22 centimeter to 29 centimeter in 1 second. All right, let me show you what I'm talking about visually. All right, I'm gonna grab the car. Okay, I'm gonna grab this car. Hold on. All right, so this car is gonna move at a constant speed all the way to 6 centimeter. Okay, now it's gonna stop for 4 seconds. 1, 2, 3, 4. Then the car is gonna move with the same speed as previously. My movement may not be accurate. Right now the car is gonna speed up for in 1 second. It's gonna speed again in another seconds. All right, when I move the car, I could make a mistake. I may not make accurate movement, but the idea is again the car moves the same speed from 0 to 6 centimeter and wait for stop for 4 seconds. Then it's gonna move again with the same speed all the way to 16. Then it's gonna speed up to, and in 1 second it's gonna get at 22, and again it's gonna speed up, and in another 1 second it's gonna get at 29 second. I mean centimeter. Okay. All right. Now we're gonna compute two things. The first one is gonna compute average rate of change. Then we're gonna compute derivative. That's which is a calculus concept. Let me do average. Average. Let me change the font. All right. First, average rate or rate of change from 0 to 1 second from 6 centimeter. So 6 centimeter is driven for in 12 seconds, right? So this is the same as 1 centimeter divided by 2 second, which is 0.5. Alright, that's the rate, average rate. Let me draw which part I'm talking about. Alright, now as I showed you previously, the car move. It may not be That's a straight picture. Let me draw. All right, the car moved first in the same speed from 0 all the way to 6 centimeter, right? And it took 12 seconds, right? So 6 is the distance and the 12 is the time, right? So 6 centimeter in 12 seconds. That's average. But if I would like to compute the rate at very close to 12. Let me say how long the car took or how far the car moved from 12 to 30 seconds. How far did the car move from 12 to 30 seconds? So let's compute that. The rate. What's the rate when the car moves? When the car moves from 12 to 13 seconds. Right? So we know that from 12 to 30 seconds, the car didn't move. The car didn't move. It stopped at that time. So the distance was 0 centimeter for 1 second. Right? So that means 0. So the car moves 0 centimeter between the 12 and the 13 seconds. All right, what about what's the rate at 12 seconds or very close second or very close to 12 seconds? Gonna be the same, 0 centimeter per fraction of seconds. Could be any fraction of seconds. All right, so the rate at 12 seconds is 0 centimeter. That's what a derivative means. This one really is a derivative idea. That's a derivative. Don't worry, I'm going to show you what I'm writing down. All right. So when the car was at 12 seconds, it moves 0 centimeter by some kind of fraction fraction seconds or milliseconds. All right. This means 0 distance again, 0 centimeter. However, when we have other mathematical question, we don't use this kind of computation. There's a different formula, and we're gonna learn that formula in the next video. All right. Also, what about here? At 26 seconds for here. All right. What's the rate? Rate at 26 seconds. Or the rate at rate between 26 and 27 seconds. All right. So at this point, well, when the car is at 16 centimeter, it took 26 seconds, right? And at 27 seconds, the car was at 22 centimeter. So first, let's compute the distance. between 22 and 16. Right? 22 minus 16. Right? It's important to put parentheses. Divided by 27 minus 26. Sorry for the calculator. All right. Now go ahead and compute the answer for me. It's gonna give you what? 6 divided by 1. 6 centimeter divided by 1 second, right? This is really the average rate between 26 and 27 seconds. What about the rate at 26 seconds? This is a derivative calculation. That's what you're gonna apply calculus. We would like to know really the rate at exactly 26 seconds. So that's in the next video. I'm going to show you mathematical formula how to do or how to compute the rate at specific instantaneous point. But in this case, it could be something less than 6 centimeter, no, less than 6 centimeter per fraction of seconds. All right. This is really basically to give you the idea when do we use calculus. Really, it is a mathematical tool that we're gonna find the rate at a specific time, because every movement, any motion, really vary when we drive a car. Our motion vary from time to time, so it's hard, to know our speed. So we apply calculus to find out our instantaneous speed, right? But if we drive with the same speed, we don't need use calculus because we know our speed at any point, right? So to watch my next video about the mathematical formula, how to compute calculus, make sure to subscribe my channel so that you can watch the formulas. Thank you.